Good morning, class. Today we'll be presenting our project, ClutterCutter, the smart, effective tool for your messy inbox. Next, please. We as students receive a ton of emails every day, leaving us a disorganized inbox and making our life more difficult than it already is. A solution to the problem will be valuable, as it helps us to save time and as a result, increase our quality of life. Next, please. To solve the problem, we came up with a machine learning solution where we create a model to learn the patterns in how we sort past emails and use this knowledge to make future predictions. Next, please. We use real-life emails in our own accounts as inputs and pre-process them with lower casing, removal of numbers, punctuations, and accurate spaces. Personal info was also removed for privacy protection. We collected a total of 1,000 emails and used data augmentation with synonym replacement and back translation to increase the total number of emails to 2850. Next, please. Sorry, next, please.
Yes,
there are 8872 unique words in our email inputs, which are sorted into 5 classes of academics, alerts, personal, professional, promotions, and events. The 5 most frequent meaningful words in each category are summarized below, with their number of occurrences. There are important indications of the label of an email, except for the personal ones. Next, please. The dataset is split into 3 subsets of training, validation, and test, with content evenly distributed across the 5 labels. Next, please.
So now we just kind of want to show you guys some examples that showcase why data augmentation was so important for our text classification problem. So here, when we didn't apply any data augmentation on our raw emails, you can see that our RNN model overfit significantly. Next slide. So after we moved data augmentation and applied it onto 35% of our samples, we could reduce that overfitting significantly. And since we wanted to get our best performance, we increased this even more. Next slide. So after applying data augmentation on 50% of our data, we ended up creating a data set that allowed our model to generalize very well. Next slide. So our model, instead of using glove word vectors, we decided to use fast text word embeddings because they have been shown to perform better on out of vocabulary words, which could be the case when dealing with unseen emails. We also compared a baseline model, which was the average word vector over each email, with an RNN, which was composed of a single jury unit. For both of these models, their outputs were fed to a linear layer with 5 neurons. Next slide. Here we have a diagram that just shows the overall data processing pipeline that moves us from our email samples to our final class prediction. Next slide. We also integrated our model with the weights and biases software to help with our hyperparameter search. So here we have the training loss and training accuracy for a subset of 10 experiments. Next slide. And combining all our experiments, we did a summary sweep, and we found that a higher batch size and a lower learning rate correlated with better accuracy. Next slide. So with this in mind, we set the hyperparameters as follows and got a test accuracy of over 96% on our test data. Next slide.
Whoa.
Oh yeah, and we have a video demo to show our model in action.
Let's see if I can make that go. Here we go. Here it comes. Maybe you should tell us what's happening.
Yeah,
We're just basically taking emails that we've never seen. Actually, Rose will talk about this then.
Yeah, I'll talk about it.
Next, please.
Okay. Oops. All right. Let's see if we can stop that. Whoa. Sorry. There we go.
Okay, so yeah, from the video example, we saw a pretty intuitive example of how our model can be applied to real life. So basically, we want to emphasize that these are emails that have never been seen by our model before, so it's correctly predicting it. Next. Thanks. So we do know that there's still flaws with our network. So for instance, we see from this confusion matrix that there was a lot of mess that was caused with the promotions and events category, and we'll see this with a couple examples in the next few slides. Next. Thanks. So this is the first example. This was a course evaluation email we got a couple of days ago. So this was incorrectly predicted. It should have been like academics, but it was like incorrectly predicted. And we think that a reason for this is because of how broadly we define our promotions and events category. And we have another example. Yeah, so in this example, this was actually an employer email, and this also got incorrectly categorized. So we see from these that like this could cause a lot of things that we don't want to happen. Next. So in general, our model has a pretty high test accuracy, but it's also really important to keep in mind the bias that might exist. So for instance, all of our data was taken from U of T students, so we don't know how well this is going to generalize on like other university students or even non-students in general. And also another thing that's we should note is the keyword frequency and how that could have like implicit bias in it. And Cindy talked about that earlier. Next. With our project as a whole, though, we learned two very important things. First is that preparing raw data takes a lot of time. It's not only just the manual cleaning, but also just like needing enough of it. And the second thing is to be very clear on the scope of our labels so that we don't have the same kind of confusion we have with the promotions and events.
Although we were able to achieve a reasonably good accuracy, there are still further things to consider for improving our model and for implementing it in an actual application with generalization for all users and additional design features, such as letting users to choose their own labels. Next, please.
That's it, I'm afraid. The time's up.
Yeah, and this is the end of our presentation. Thank you.
Okay, good. That's great. Good. It's really, really interesting. It's great to see these NLP things because I think that's really important. One comment I would make that relates to the data augmentation observation you made is 150 total emails. Seems like a very, very small amount in this NLP world. And so it sort of makes sense to me that you're, by augmenting your data and creating more examples, you've got better results. I get that it's hard. I don't mind that, and it's not really a criticism. I'm really glad you did your own data collection. I think comprehending how hard that is, and that's where you're going to add, it's a key place where you're going to add value in the future. So one quick question about your labels. Are those classes overlapping? Like one email can be two different kinds of emails. Is that true, or were they supposed to be mutually exclusive?
Okay, so yeah, so basically for like our categorization, there's definitely going to be like emails that kind of go in both. So like with us, what we did is like we kind of got together as a team and really, really strictly said which specific ones would go where. So like that's so yeah, that's definitely.
So I need to answer the question. Was your classifier a mutually exclusive classifier? It only produced one answer?
Yeah.
Yeah. Okay. But your data actually was not mutually exclusive, and somehow you just made a hard decision about which category it went into. Is that correct? Okay. Yeah, that's important to that's an important underlying thing to talk about the nature of your data that occurred to me. Yeah, a little confused. Awesome to see this email, by the way. I've never get to see that one. You said that your confusion matrix wasn't so good. This looks like the best confusion matrix I've ever seen. There's thousands in the diagonal and single digits everywhere else. Why did you say this is not good?
It's like not good, but we're just saying how like if you look specifically in like certain squares, there's the most confusion was with like promotions and events.
Yeah, but you got to use your engineering. Like the first thing they teach you in first year here is if you're within 5%, it doesn't matter, right? Isn't that the most surprising thing you hit in first year? You go, why are people so imperfect? And so you're supposed to remember that one when you look at 4 versus what is that? That's not 1,000. That's 110. So maybe it's not that. Yeah, still it's a small number. Okay. Yeah, it's awesome that you used weights and biases. Glad to see somebody pick that up. I didn't really understand. No, where is it? It's back here. You said stuff and there's things wiggling on the screen, but I didn't quite get it. Yeah. Can you maybe quickly say again what you said and why this shows what you said? And by the way, that's a lesson for all presentations. You go, here's my conclusion and here's why the data says it's true. But this looks like, what did you say and why is it true?
Right. So how this is plotted, I suppose, is that each line represents a certain like test run. So then that test run has those parameters set. So then if we look at the ones that are like colored yellow, which correspond to like high test accuracy, you kind of see that like there's a general trend that like the curves go all the way down towards a lower learning rate. As well, there's a lot more higher like yellow runs around like a higher batch size.
Oh, right. That's how you interpret this. Yes, it's not as typical looking plot of X versus Y. So these lines that are doing really well up here. I guess you didn't have the pointer. One downside of my presentation method. So these lines that are doing well up here are all flowing down through a low learning rate, or this learning rate. And then I'm not sure anything else is consistent across here. a hidden dimension. Maybe there's not much else to say.
I guess there was also we didn't include this in our presentation. There was also another like smaller like correlation, I guess, graph that we showed. It just shows you like the correlation between like batch size and test accuracy, like for each variable specifically.
Sure, and there's not enough time to present that here, but please do put that in your final report. That's really interesting, and maybe you'll motivate other people to take a crack at weights and biases. Did you like it, or was I overselling it when I talked about it?
It's really easy to use, so I quite enjoyed
it. Here, it's fantastic, by the way, and it's great to see this thing. Ash, anything from you? And you don't need to repeat anything I said. It only has to be new.
It was great, very clear. In general, I guess for future presentations, when you have like visualizations like the summary suite, I always find it useful to add maybe even a line of text just briefly summarizing or explaining what exactly that might be, just to help the audience more clearly contextualize what that is. But it was fantastic. Good job, folks.
Great. Comments from anyone else? Questions, suggestions, applause?
I do have a question regarding the data augmentation. So I'm just wondering, so there's some data augmentation, there's some increase in the validation accuracy. Is it because the model is more generalized, or is it because after augmentation, there are more repeated data in both validation and training? Would this also cause an increase in the accuracy?
Well, overall, we wanted our data augmentation to kind of make samples that are at least relatively different. So with our data augmentation, we did 2 steps. We had both batch translation, which is translating to another languages and then translating back to English. So that ends up shuffling the word order and changing some of the meaning. And as well, synonym replacement replaces a lot of the terms with a synonym, I guess. So then by generating new samples that way, a lot of the samples, sure, there might be some overlap in terms of the underlying meaning, but the word order and just the words that are the vocabulary that's chosen are most likely different. So then that should help our model generalize a bit better.
Okay, thanks.